And then we're going to welcome our next speaker onto the stage, Sanket Singh, who's going to be talking about 6-star rating, or rather, so who's going to be talking about when RPC met Python. Sanket Singh is at 6-star rating at HackerRank, software engineering at Google India, a developer working on Google Pay used by 150 million users in India, active experience full stack web developer with over 40,000 YouTube subscribers and who has mentored over 25,000 budding software engineers. So without any further ado, please put your hands together for Sanket Singh.
Okay. Hi everyone. Good afternoon. So today we are going to talk about a very interesting technology, gRPC, right? So first of all, I'm pretty much overwhelmed by the scale of the event. So thanks everyone for joining, right? So before we actually start, just for a set of introduction, who am I, why I'm here? So I'm Sanket Singh. Currently I work as a software engineer at Google. So in Google, I work with the Google Pay India consumer application team as a full stack engineer. We handle everything around the UPI infrastructure that empowers transactions nowadays in India at a very high scale. Prior to Google, I worked as a software engineer at LinkedIn, mainly in the enterprise provisioning team at LinkedIn. Like in my free time, I do spend some time in training a bunch of students online, offline in different computer science tech regarding data structures, algorithms, DBMS, networking, JavaScript, Python as well. I'm a big Marvel and DC fan, so you might see a bunch of memes here and there throughout the slide. So just bear with me. So what to expect out of this session? We are going to talk about what is gRPC, and we are going to talk about why exactly do we need it. Because until or unless we know the root cause analysis, the RCA of the counterpart that is already available to us, that is REST, we won't be able to actually embrace the benefits of gRPC, right? So we're going to talk about why do we actually need it in the first place. We're going to talk about the comparisons with other conventions like maybe REST, SOAP, etc. We'll try to kickstart a sample gRPC server and client in Python. I have a bunch of code snippets ready in the interest of time. So let's just start. So first of all, our favorite REST. I believe anyone who has actually interacted with any kind of developer environment, maybe with a client server kind of infrastructure, you must have heard about REST APIs, right? Most of our developer community, most of the products, most of the companies that nowadays you will see are somewhere somewhat heavily relying on the REST infrastructure and the REST conventions, right? That gives us the first advantage of REST, that it is widely accepted and heavily used. If you are someone who is new in this overall, let's say, client server architecture, you'll find tons and tons of articles, Stack Overflow support articles, different videos, tutorials, a lot of things to get you started with REST so that you can boot up your first REST API server and just start up your projects. It's pretty much flexible and easy to use. No matter whatever are the advantages or disadvantages, REST is pretty much flexible. For a good amount of time myself, I interacted with a lot of REST services through our client interfaces. And the big part that enables REST, or I would say helps REST to empowers multiple applications, is that it is compatible with browsers and other applications as well. You have some predefined set of conventions because we have been using REST for quite some period of time. So it's like we have good amount of status codes. We know that, okay, if this is the request structure, if this is the response structure, this might be happening in the overall request response lifecycle. If you see a API request URL, you see the method type, you will be able to more or less comprehend or at least judge that this API might be doing something around this, right? So we have predefined set of conventions. Of course, They are recommendations. Even if you don't follow it, nothing is going to break. One very important part about REST is that there are dedicated frameworks and libraries like Ruby on Rails, Python, Django, etc. that supports REST out of the box. I worked with Ruby on Rails for quite some time, and one thing that I realized that these frameworks have coupled themselves with the REST conventions so heavily that if you use all the REST conventions properly, they are going to do a lot of things out of the box just like magic. But the moment you start deviating yourself here and there, maybe you can face a hard time as well. But we cannot deny the fact that having out-of-the-box support for REST applications, scaffolding REST applications through Django, Rails, and these frameworks are pretty useful. And if you're a beginner, or let's say your project is working on a very small scale, having these kind of benefits really helps us a lot. Now, let's talk about gRPC. Now, we have, or maybe you have already heard about RPCs, remote procedure calls, right? Now, the gRPC is an open source RPC system that was developed by Google in 2015. Just FYI, there is no official documentation that the G in the gRPC is Google RPC. So we just call it as gRPC, okay? Now, there are some good, interesting benefits that gRPC brings out of the box. And having few things out of the box makes a lot of sense because then our own effort is going to be reduced a lot. We'll talk more about it, but just for a glance, it uses HTTP 2.0, right, out of the box. It uses language neutral protocol buffers that we also call as protobufs. We'll talk about protocol buffers, very interesting stuff to discuss. It's fast, it's secure, it supports things like auto load balancing and more. So we'll throw some light on gRPC and maybe why you should start exploring gRPC as well. But the big question that should come to your mind is, it's been quite some times and we have seen quite good scaled applications throughout our history. Like in last 10 to 15 years, we have seen application handling multi-million order of scale in terms of users, in terms of transactions and whatnot. So why now? Why do we need something new and start shifting towards that? So let's talk about problems with REST. Now this is a bit opinionated. You might see that as a problem or you might not. So these are something that I feel definitely that is worth considering to look for an alternate option. Now we know that with REST, the standard messaging infrastructure is powered by JSON, JavaScript object notation. Now, one big issue that comes with JSON is the type checking part, right? This, although introduces a lot of flexibility that you don't have to write a lot of types, and overall the coding ability of in terms of a developer productivity, if you see, you can assume that might increases, but still type checking is something that causes a lot of bugs in production, right? Apart from that, the semantic versioning on the API change is again a problem. If you want to do streaming, again, there is no out-of-the-box support for that. Although you can change the next one, that is the default support of HTTP 1.1, you can manually upgrade it to HTTP 2.0 and later, but at least the out-of-the-box support is still HTTP 1.1. The validations, again, it is very closely and tightly coupled with type checking, that you have to do manual validations on your own, right? And one very interesting fact that not a lot of people talk about is that whenever you see any REST client libraries, let's say for Python, you might be having a different set of libraries. For Node, you'll be having a different set of libraries. Every set of libraries is more or less managed by different open source orgs. And let's say, for example, at some point of time, the libraries in Python do migrate to the latest version of HTTP. You cannot expect the same from other tech stacks. Let's say you cannot expect that from the overall code infrastructure for Ruby as well, right? So maintenance of different client-side libraries and different implementation corresponding to them, again, makes it a lot of hassle, right? That's where gRPC comes to the rescue. Now, as I said, gRPC comes with the default HTTP 2.0 support. Instead of JSON, the message format that you use is protocol buffers. Now, this is a very interesting and I would say one of the most important aspect of gRPC that empowers most of the stuff. Using protocol buffers, you can actually define strict API contracts. Now, that's very much important, right? Because with normal JSON and normal REST APIs, you cannot have strict API contract that you always expect a specific type of response, you always expect a specific type of request. You can have manual validations, of course, as I said, you can have manual middlewares and manual validations, but if something is giving you out-of-the-box support for these kind of validations, why not explore that? Apart from that, it has built-in code generators. We'll talk more about it. For different tech stacks, for example, let's say you want to use gRPC with Ruby, or maybe gRPC with Python, or maybe gRPC with Node, it has inbuilt code generators for different technologies. So you can focus more on your consistent implementations, and rest everything will be handled by gRPC. It has inbuilt support for load balancing. You can do unary, server or client side, and even bi-directional streaming. It's a bit more secure, a bit more fast, and as I said, gRPC is definitely faster than REST. There are multiple reasons for that. We'll go through a few of them one by one. Now, first of all, let's talk about how is it faster than REST. Okay? Now, because the message format that you are using instead of JSON is protocol buffer. So what happens with protocol buffer is, when you actually prepare protocol buffer, this gets serialized and then later gets deserialized in the form of binary, which actually reduces the message payload size. Smaller payload size means lesser load on the network. Apart from that, it by default, out of the box supports HTTP 2.0, right? Along with that, there is inbuilt support for load balancing and inbuilt support for bi-directional streaming as well. Now let's focus a bit more on protocol buffers. So here on your screen, there is a very small example that I have taken from a Medium article. If somebody wants the exact link of that article, I have linked that in my presentation as well, right? So there are three kind of message formats coming into the place. The good old XML that you might have seen with the SOAP infrastructure, the JSON that you generally use with REST, and at the top, there is a serialized protocol buffer, right? Now you can see, bigger the message format will become, the XML and the JSON format becomes equally heavy, right? Whereas, if you carefully look on the protocol buffer, this actually serializes your message in the form of a binary, right? And all of this logic is inside the facade of gRPC. You don't have to care anything about it. You just have to prepare your protocol buffers. We'll see how you can prepare your protocol buffers, and everything will be sorted on your end. Now let's focus more on protocol buffers. Now you can see, let's assume a very simple scenario. Let's say you want to set up an API that is going to exchange a particular message of a person. This message is going to contain some details of the person, let's say name of the person, some unique ID that you want to define, and let's say the email. Now, because you want to define protocol buffers, and one very important stuff about protocol buffer is, it is language neutral, right? So it doesn't matter what your code base is actually set up in, you can actually get started with protocol buffers pretty much very easily. Now, if you carefully see that there are specific types that we have defined, and we can also define what parameters are required, what parameters are optional. For example, the name parameter, it is default defined to be of type string. You cannot assign anything else in the parameter name, and you cannot send the payload without name, as it's a required parameter. Same thing happens for ID. But for email, it's an optional parameter. So you can send the email, or maybe you can avoid it. Similar type of modifiers are available with protocol buffers. For example, let's say you want to send an array of some strings. So there is a modifier called as repeated. you can mention that, okay, this parameter is going to be an array of something, right? So in this way, you can conventionally define what kind of message is going to be exchanged between the client and the servers. And once you have defined this protocol buffer here, then based on whatever is your language to write, for example, you're writing in Java, Python, Objective-C, C++, Ruby, Kotlin, anything, you get a set of builders that by default get generated from the compilers that are given to you by gRPC. You can see there is a small example from Java, right? There is a automatic person builder class that you will get, and then you can set up all of the parameters. Whatever are the mandatory required parameters, you have to actually send them. If something is optional, for example, email, you can even skip that. All of this is going to be by default available to you just by writing a simple protocol buffer file, right? So the best part is it's language neutral. Most of things that you will write in a protocol buffer more or less is like English. I'll show you one small example where I have set up a small RPC as well, where we have to just define that, okay, this is a RPC format, this is going to be the request, this is going to be the response, and later you can implement your implementations already. Now, one very important stuff with gRPC. As I mentioned, that with REST, different technologies will be having their own set of client libraries. With Python, you'll be having separate set of client libraries. With Ruby, you will be having separate set of client libraries. And you cannot expect both of the tech stacks to be on the same page in terms of what internal, let's say, HTTP version they are using, or what streaming purpose they are using, anything. But with gRPC, there comes a very interesting advantage. All of the different stacks that currently gRPC supports, and it's quite a lot, whatever stacks are supported, all of them will be having a consistent behavior in terms of the specs that they are internally using, because all of this is managed by Google, right? So you can actually go to the official gRPC website and actually see what all tech stacks are currently supported. They are still expanding the support for more languages as well, but I guess till now, more than 10 odd languages are supported with gRPC. Now let's see a few examples that I have actually prepared in terms of, like, if let's say you want to set up a very simple gRPC client and a server using Python, how can you do that? Okay, cool. Now you can see there is a simple protocol buffer file. Okay, so we have the latest version of protocol buffer as Proto 3. So you have to mention which version you are going to use. You'll define what is the package. And if you carefully see, there is this service parameter that I have defined. This service parameter is going to define all of your RPCs. So you can see there is going to be a to-do service, inside which there are going to be two RPCs, create to-do and read to-do. You can see, you can very easily define RPC as create to-do. The request object is of type to-do item, and the response object will also be of type to-do item. In read to-dos, the request object will be of type to-do request, and the return type will be of to-do items. Okay? And below, you can actually see the message format for to-do item and to-do items, right? If you carefully see to-do item, you can see there is a ID and a text parameter that we have defined. In to-do items, because there will be a club of to-do item, I have defined a repeated parameter, so you can assume it's going to be an array of to-do item. And at last, there is a to-do request, which I have defined as an optional argument ID. Because a lot of time, let's say if you see with the world of REST, in REST, generally, let's say if you want to create a CRUD API, right? And you are mainly focusing on the read part. So let's say you will make an API like /API/v1/to-dos/1. In that case, you will get the first to-do. /2, you will get the second to-do. But if you do /API/v1/to-dos, and that's it, then you are going to get the list of all of the to-dos. So if you want to just mimic something like that, you can have a to-do request object like this, which will be having an optional ID parameter. If you don't pass an ID, maybe we can send all of the to-dos that are stored in the database. And if you do pass an ID, then we are going to specifically fetch that particular ID and get the response back. In this way, in this simple way, you can actually define your protocol buffers, right? Now, one very important benefit that I feel with this protocol buffer is that without anyone reading your core implementations, if somebody just reads your protocol buffer, they will be able to actually understand what are the different parameters that are coming in the message request, what are the things that you can expect in the response, what is optional, what is required, what are the different RPCs available, and what not. And trust me, with my own experience working with this technology at Google as well, it really decreases the overall time for debugging. If I have to read the RPCs that are available in some XYZ service, I don't have to actually go through the whole code of the XYZ service. I just go, read the protos, and more or less I'm able to understand, okay, what all things are exposed, what are the message request formats, and what to expect. Once done, what you can do is, for every language, there are dedicated compilers that are available. What they are going to do is, they are going to take this protocol buffer file, and based on this protocol buffer file, they are going to generate some code. So let me show you as an example. So you can see, these are the two generated files, to do pb2.py and to do pb2grpc.py. You don't have to bother a lot about what exactly these files are doing. They are majorly going to do just one simple thing. They are going to make sure that at any point of time, you are going to hit something like a to-do service with a to-do item and a to-do item or a to-do request kind of an object. All of the builder classes are available to you that you can start using and write your implementations. So for any language, like let's say if you don't want to use Python, you want to use something else, you can have dedicated compilers for that. You can check out the documentation for gRPC. I believe it's pretty much verbose. Then what you can do, you can start defining your service. You can see I've already defined inside the server a basic to-do service, right? Now, whatever are your RPCs, you can actually define your RPCs here again, the create to-do and the read to-do RPC. It's a very simple client-server example that I have prepared, right? When you're trying to create a to-do, what it will do is, it will just append that in a array, right? I have not integrated any DB or anything, but I believe that should be a pretty simple task to do. In the request, as you can already see, the request format contains an ID and a text. So this request object will be having an ID, and this request object will be having a text. And I'm just appending this simply inside an array. When I do read to-dos, I'm just directly going to reply with all of the to-dos that I'm having, right? That's how you can actually define your servers. Of course, your servers will be having much more complex logic than this, but this is just a simple example that I have prepared. And then what you can do is you can start setting up your clients, right? So I have a very simple client side as well, which actually just connects to the port and start making a request for create to do with a very basic simple to do object here, to do item object here. It makes a call to create to do. And then once a create to do call is done, it makes a call for reading the to dos. That's it. It's like simple coding implementation that you have to do based on this library. Right, so you can read the whole code implementation here as well. I have attached that in the presentation, right? And once done, then you can boot up your gRPC server and boot up your gRPC client, and both of them will be able to connect. So in case you are doing any kind of two different microservice communication, instead of REST, you can start exploring gRPC, right? Now let's start doing some pros and cons and comparison. One biggest con of gRPC is that if you are a beginner or if you have a very simple use case, it's too much to do, right? I can boot up a very basic Ruby on Rails server or a Django server and write a very basic Python API in REST in like 10 minutes. But to get started with gRPC, I believe there is a learning curve, there is a friction. But along with that, there is a dedicated pros that you get as well. You get consistent APIs, you get type checking, right? You don't have to do manual validations. It's a bit fast. And corresponding to REST, you don't have to manage your client-side libraries yourself, right? There are some noticeable differences in the overall conventions of REST and gRPC. For example, at any point of time you see a REST URL or a REST route, it is focused more on resources, right? For example, here to-do can be a resource or a user can be a resource. Whereas if you see any gRPC actions or gRPC routes, there are more focused on actions. For example, create to-dos. Instead of saying something like slash to-dos, we call it as create to-dos or read to-dos. That what exact action you want to actually do, that's something that you mention. So of course, there are dedicated pros and cons on both the sides. I believe if you have a very small, simple, time-constrained project that you have to actually complete as soon as possible, maybe you are doing some POC or something around that, I believe using REST is definitely a good choice. But in case you have to cater a good amount of scale, you are having a good amount of traffic, and you are not going, you don't want to spend a lot of time in manual validations, you want consistent APIs, gRPC is definitely worth a shot. A lot of projects, apart from Google as well, I've seen people have started, I would say, integrating gRPC in their projects, and I've seen good results as well. So that was all about the dedicated discussion around the REST conventions and the gRPC conventions. I believe it's worth a shot to actually give a try to write some basic protocol buffers and boot up a very basic server and actually see things in action. So yeah, that was all for this particular talk. And I believe you got a good comparison around what is gRPC and why you should use it. Thanks, everyone.
And we probably have time for at least one question. So anyone with any burning questions? Oh, several hands. OK. All right. Microphone is coming.
Thank you very much for delivering the good lecture. I am Azhar from Pakistan. And my question is, let's suppose if we keep continuing with the REST API instead of gRPC, so do you think we will face a problem in the future? And there is a chance that the features that you are referring in the gRPC, these features may come in the REST APIs in the future. So is there any, drawback?
So I would like to answer this with respect to something not exactly REST and gRPC, but very much similar. I believe a lot of people might have heard about TypeScript and JavaScript, right? Now, what new thing TypeScript brings onto the plate? Type checking. That's it. Whatever applications that we had running in core JavaScript are still pretty much good to go. I work with a good amount of front-end code of LinkedIn, and still they use very heavily plain raw JavaScript instead of migrating to TypeScript. But nowadays you can see a lot of new applications are migrating towards TypeScript because definitely it gives us a hassle-free experience in terms of debugging effort. I believe if you are able to reduce the debugging effort of the developer, it is eventually going to affect the overall cost and the revenue of the company. Similar thing I believe exists with REST and gRPC. I still believe for a very long period of time, good amount of application are still going to go towards REST, despite the fact that you have difficulties with type safety and everything. But I believe if you are having a very huge amount of scale, for example, the scale at which the social medias or maybe let's say products like Google Pay, let's say for example, in our country, India, we have multiple payment applications like PhonePe, Paytm, Google Pay, which handles millions of transactions a day. If you're working at that particular scale, I believe it's worth a shot to explore something like gRPC because, again, as I said, the biggest advantage that I see is developer productivity, right? There will be an initial learning curve, but once you are through with that particular phase, the type safety is very important. The protocol buffers are pretty much very fast, right? And the overall, I would say, lifetime of a request, the overall time consumed in the overall request response cycle definitely reduces. But in one word, if I have to answer your question, that what I feel in coming, let's say 5 to 10 years, is REST going anywhere? No.
Well, thank you. That's all the time we have. Please, another warm applause for Sanket Singh.